This aircraft breaks every rule of flight. It has flat panels where wings should curve, sharp angles where air should flow smooth, and the body looks like a shattered mirror. Engineers said it was unstable in pitch, roll, and yaw. Test pilots said it wobbled into the sky, and the math wasn't really sitting right. It just couldn't generate enough lift. Yet somehow, Lockheed made it work, and this thing became the most feared attack jet of its generation. This is the F-117 Nighthawk, the plane that should not fly. By the mid-1970s, the Soviet Union had built the most advanced air defense network in history. Surface-to-air missiles ringed every strategic target. Radar stations tracked everything in the sky. American bombers and fighters could not penetrate these defenses without catastrophic losses. The writing was on the wall. During the Fourth Arab-Israeli War, Israel lost 109 aircraft in just 18 days, all because of SAMs. If NATO forces suffered similar losses against the Warsaw Pact, their entire fleet would be gone in under 2 weeks. DARPA needed a solution, not faster planes, something the Soviets could not see at all. The answer was stealth, but no one knew how to build it. Radar works by bouncing radio waves off an object. The bigger the reflection, the easier the target is to track. Conventional aircraft, with their curved surfaces and metal bodies, reflected radar beautifully. A typical fighter like the F-4 Phantom had a radar cross-section of about 6 square meters. Soviet radar could track it from 100 miles away. But what if you could make that reflection 1,000 times smaller? That was the challenge. Build an aircraft invisible to radar, make it combat capable, and somehow make it fly. In 1974, DARPA secretly awarded contracts to 5 defense contractors. Lockheed was not one of them. They had been absent from the fighter jet industry for too long, but Lockheed formally requested permission to participate. DARPA refused because of insufficient funds. After intense lobbying, they were finally allowed in. But without a government contract, they were on their own dime. Lockheed had built the U-2 and the SR-71. Impossible projects were their specialty. But this was different. The breakthrough came from an unlikely source, the enemy itself. A Soviet physicist named Pyotr Ufimtsev had published a paper on radar reflection. The CIA translated it. Lockheed's engineers studied it obsessively. Ufimtsev's equations revealed something remarkable. Curved surfaces scatter radar energy in all directions, but flat surfaces could direct it away from the source. If you angled the panels precisely, the radar would bounce away, never returning to the source. A Lockheed mathematician named Dennis Overholser wrote a computer program called Echo. It calculated exactly how to arrange flat panels for minimal reflection. The result looked nothing like an airplane. It looked like a geometric toy, all sharp edges and flat faces. Engineers nicknamed it the hopeless diamond. To test the theory, they built a wooden model, took it to a radar test range, fired up the radar. The operator could not detect it. Then a bird landed on the model. Suddenly, the radar lit up. The operator was not seeing the model, he was seeing the bird. The stealth worked, but defeating radar was just the beginning. The shape that made the aircraft invisible made it aerodynamically terrible. Flat panels do not generate lift efficiently, they create turbulence, unstable airflow. The F-117 needed massive wing area just to stay airborne. Worse, the faceted design made it inherently unstable. In all 3 axes, the aircraft wanted to tumble in every direction. Ben Rich, head of Skunk Works, openly admitted that the F-117 would not be high performance. It would not carry much payload, and it would be aerodynamically unstable, but with computers, it could be controlled. Lockheed borrowed the fly-by-wire system from the F-16, 4 redundant computers making 30 corrections per second. The pilot's inputs went through software that constantly adjusted the control surfaces. If the computer failed, the jet would tumble out of the sky instantly. No human could fly it manually. The first prototypes were called Have Blue. They proved just how dangerous this gamble was. Test pilot Hal Farley described the maiden flight. The jet wobbled into the sky. Even with lead ballast in the nose for balance, it barely held together. Both Have Blue demonstrators crashed. The both were short on the lift and very prone to excessive sink rates. But the stealth was working perfectly. Lockheed pushed forward. The production of F-117 didn't fix the aerodynamics. Instead, Lockheed made the computers faster, more responsive, 4 redundant flight control systems running simultaneously, cross-checking each other 30 times every second. Every input from the pilot went through software first. The stick said, "Turn left." The computer calculated how much the unstable airframe would over-rotate. Then it applied exactly enough control surface deflection to achieve the turn without departing controlled flight. Pilots described it as flying on a knife edge. The jet wanted to tumble constantly. The computer was the only thing stopping it. According to one instructor pilot, one revolution of the stick in any direction was all you needed. The computer did the rest. Because if the computer stopped, you had maybe 2 seconds before the aircraft became unrecoverable. And the interesting thing is, this wasn't a bug, it was the design. The F-117 trades natural stability for invisibility. Every single flight was a bet that the computers would keep working, and every night, when pilots climbed into that black cockpit, they were trusting their lives to software keeping an impossible aircraft in the air. It wasn't graceful, but it worked. The F-117 program was classified at the highest levels. Flights happened only at night, only at Groom Lake. Under total secrecy, the Air Force invented elaborate cover stories, like fake accident reports, and ALS project names. Pilots trained on A-7 Corsairs, first to learn the basic handling profile, and then simulators. Only after hundreds of hours did they fly the actual jet. Everything about the F-117 was counterintuitive. No bubble canopy. Windows were covered in radar-absorbing coating. Even the pilot's helmet could create a reflection, so visibility was deliberately limited. No afterburners. Top speed barely 600 miles per hour, which was intentionally subsonic. Air intakes were covered with fine mesh. Exhausts were flattened into a wide slit that mixed hot gases with cool air. Every detail traded performance for stealth, and it worked. The radar cross-section was smaller than a marble. Compared to a conventional fighter, it could get 90 to 98% closer to enemy radar before being detected. It could fly directly over air defense systems, totally undetected. By the late 1980s, 59 of these jets were operational. The world still did not know they existed. December 1989. Panama. The F-117 flew its first combat mission, striking a Panamanian Defense Force barracks. Target destroyed without any radar locks or warnings. But the real test came 2 years later, January 1991. The most heavily defended city in the world. Soviet-made SAM batteries, layered radar networks, and thousands of anti-aircraft guns. On the first night of Desert Storm, Nighthawks flew directly into downtown Baghdad. They struck command bunkers, communication centers, and air defense headquarters. Over the course of the war, F-117s flew 1,300 sorties. They represented just 2% of coalition aircraft, but they struck 40% of strategic targets. Not a single jet was damaged. Not one. Pilots described flying at night, watching tracers and missiles arc blindly into the sky, searching for them, but never finding them. This was the plane that was not supposed to fly, but it changed warfare forever. The F-117 flew in every major conflict for 2 decades. Panama, Iraq, Kosovo, Afghanistan, Iraq. Again, only one was ever lost in combat. Shot down over Serbia in 1999 by a SAM battery using outdated VHF radar and creative tactics. It was an outlier, a statistical improbability. If you love knowing about aircraft, then you will love these 101 facts about B-2 Spirit. Also, subscribe the channel and hype this video.